Hi everyone. In your next unit you're going to study acceleration. And acceleration is something that in the past students have struggled with. So I want to clear some things up right away before we get started. Acceleration is the rate at which velocity changes. Now remember, velocity is a vector. We've seen several vectors, so let's review those real quick. Position is a vector. It's the location relative to a reference point. Remember, vectors give both magnitude and direction. So if I have a reference point right here, this is my 0 position, I could be 1 meter in front of it. That would be to here. This is a vector because that positive 1 meter, that tells me which direction in front of the reference point I am, and the 1 meter tells me how far. I could also be negative 1 meter, so this would tell me a position as well. I'm 1 meter behind the reference point. Those are both positions. Now if the position changes, that's what we call displacement. Also a vector. Okay, if I have a displacement of 1 meter, positive 1 meter from right here, then I'm going to end up going to the right or in a positive direction 1 meter. So my change in position from here to here, if this is 2 meters, is 1 meter because 2 minus 1 is 1. Now if I had a negative displacement from this position of 1 meter, I'd end up at the reference point. So again, displacement, the delta x, which has units of meters, tells me how far and in what direction I've gone from where I've started. It's a vector. The last vector that we know about is velocity, and it's the rate of change in position. Velocity is a little bit interesting because just like everything else, it can be negative or positive. A negative velocity doesn't mean necessarily you're moving backwards. What a negative velocity means is that your position is becoming more negative. Position becomes more negative. Now, if you think about that, that's an interesting thing to say, because if you have a positive position, how does your position become negative? Well, if you have a positive position, to become negative, it has to get closer to the origin, past the origin, and then go behind it. Okay? If you have a positive velocity, then position becomes more positive. So if you have a positive position already, you're moving in a positive direction. If you have a negative position, if you're over here behind the reference point, then you're going to come up to the reference point, maybe pass it. So the negative here is indicative of which direction we're moving. It's indicating, are we moving left or are we moving right, essentially. Now acceleration abstracts that one more step. So acceleration is the rate of change of velocity. Since velocity is a vector, acceleration is also a vector. It's calculated by taking a change in velocity divided by time. Now if we take a look at the units on that, a change in velocity is going to have units of meters per second, time has units of seconds, so that's an invert and multiply, so this gets me meters per second times 1 over seconds, which equals meter per second squared. I'll also write that as meters per second. You'll notice that's velocity per time. It's not telling me how fast anything's moving. It's not telling me in which direction anything's moving. It's telling me if my velocity is changing, and if so, at what rate. So there is a such thing as positive acceleration. Positive acceleration means velocity becomes more positive. Now, let's take a look at what that means. If a velocity is becoming more positive, and let's say I'm going to start with an initial velocity v naught equals negative 4 meters per second, and I'm going to have an acceleration of 2 meters per second. Then after 1 second, this means my velocity has increased or become more positive by 2 meters per second. So that means after 1 second, my velocity is negative 2 meters per second. You'll notice it slowed down from 4 meters per second to 2 meters per second, and it became more positive because negative 2 is more positive than 4. And then if I go 1 more second with this acceleration, t equals 2 seconds, my velocity will be at 0 because I've gone from negative 2 meters per second, and my velocity has become more positive by 2 meters per second. So I actually stop for a split second. But if the acceleration continues, and I go to t equals 3 seconds, now all of a sudden my velocity is 2 meters per second, because every second my velocity became more positive by 2 meters per second. That's what a positive acceleration of 2 meters per second means. You'll notice it doesn't mean it's speeding up or slowing down or even which direction it's moving, because the whole time of this example I had a positive acceleration of 2 meters per second. But initially we were moving maybe to the left at 4 meters per second, then we're moving to the left at negative 2 meters per second, so we're still moving to the left but we're moving slower. Then we're stopped. You'll notice here I still have an acceleration. Even though I'm not moving, I am accelerating. And then at 3 seconds I'm moving positive 2 meters per second, which is faster than 0, and now it's in the opposite direction. So positive acceleration does not indicate positive direction, it just means my velocity is becoming more positive. The negative argument is very, very similar. If I had an initial velocity of, say, 8 meters per second, and I have an acceleration of negative 4 meters per second, then what's going on? Well, at t equals 1, my velocity is becoming more negative by 4 meters per second every second. So 1 second after this, I'm only moving at 4 meters per second. So I got slower by 4 meters per second, but I'm still moving in a positive direction because I still have a positive velocity. If t is 2 seconds, then my velocity is equal to 0. I'm not moving at all, I've slowed down and stopped. But at t equals 3 seconds, I've sped back up to negative 4 meters per second. I've sped up, but I've sped up in the opposite direction. So again, a negative acceleration doesn't mean I'm moving in a negative direction or in a positive direction, or if I'm moving fast or slow. It just means that my velocity is becoming more negative. Now, this is an acceleration of 2 meters per second. This was an acceleration of negative 4 meters per second. The magnitude tells me how quick that acceleration is. Here it took 3 seconds to change my velocity by 6 meters per second. Here it took 3 seconds and I changed my velocity by 12 meters per second, from 8 meters per second all the way to negative 4. So this is a greater acceleration. If you felt that, it would be a sharper jerk. So keep that in mind. Acceleration is not velocity. It doesn't tell me direction. It doesn't tell me speed. It tells me if my velocity is becoming more positive or more negative and how quickly it's changing.